All right, when is your test? Tomorrow. 6 pages, no calculator. Sounds really scary, but you guys can pull this off, and this review is really going to help you be able to do that. Your job to get full points on this review right now is to grab a pencil, take some notes, listen to everything I say, write down what I write down, understand, ask great questions. That's your job. If you can do that, you get a 10 out of 10 on this assignment. Got it? Think we can handle it. Now you just had lunch, but let's try to stay awake. This is good stuff. You need to know this stuff. Number one, I realize number one in and of itself has nothing to do with limits, but you do have to know one or more of these on that test for sure. Some of you guys are still struggling with some of this. If you struggle, or even if you don't, you can always draw yourself a little diagram off to the side with a little unit circle, but you only need this point, and this point. You probably don't need it any more than that. This one is 1, 0. This one is 0, 1, and this one is negative 1, 0. You just have to remember it's cosine comma sine, which is not that hard considering it's an ABC order. So the cosine of 0 radians, that's over here. Cosine is 1, sine is 0. Tangent, some of you still are unsure of. Tangent is sine over cosine. So in this case, it would be 0 divided by 1, which is, thank you, pi over 2. That's 90 degrees. Cosine comma sine, so 0 comma 1. 0 is cosine, sine is 1. Tangent, 1 over 0 is undefined. That's where you're going to find an asymptote. Good job. At pi, cosine's negative 1, sine is 0. What's tangent? 0. Be ready for that tomorrow because you won't have a calculator if it shows up in a problem. Number 2, it says, what's the limit as x approaches an asymptote? Now, there's a couple of answers on this, actually. Here's a little grid. You don't have to draw this, but I do want you to watch. Let's say this is your asymptote, and let's say it's at, I don't know, 4. As this graph approaches the asymptote from the left, what has to happen? It's got to go straight up or straight down. What if it approaches it from the right? Straight up or straight down. So you only have 2 choices if it's a one-sided limit. So one-sided limits, meaning coming from just the left or just the right. For one-sided limits, it's either going to be positive or negative infinity. That's the one where you take the crazy number, like 2.0001, and you plug it in and you see what it's approaching. If it is a two-sided limit, we need to talk about this. Two-sided limits. You're coming in from both sides at the same time, so they both go up, which if they both went up, what's the answer? Positive infinity, or I would take does not exist. If they come in from both sides and they're both headed down, it would be negative infinity or does not exist. If they come in and they go different directions, what is it? So what's your safest bet if it's a two-sided limit and you know it's an asymptote? So just put does not exist. I will take either answer if either answer is true, but I will definitely take does not exist. Not all professors feel that way. Do what? One-sided means you're only answering as it comes from the right, or just as it comes from the left. Two-sided means you're looking at both at the same time. Great question. All right, any other questions about 1 or 2? You okay? Spencer, Marina, you guys okay? Okay, number 3. These are your special limits. These are the ones you're supposed to have memorized. What's the limit as we approach 0 for sine of x over x? 1, and the other one is 0. Now, 2 things I want to say about this, and I really hope you're listening. If this says the limit as x approaches pi, is the answer still 1? No. And most of you guys know that because I kind of brought your attention to it out loud. Please don't go so fast tomorrow that you don't read this little bitty number right here, because that does matter. If it's a 0, it's 1. If it's not a 0, plug it in and figure it out. Please read every little teeny tiny mark on that test. This little guy right here, what I want to say about that is, as we approach 0, let's say the numerator said cosine of x minus 1. Is the answer still 0? No, probably not. So be really careful and make sure you have not just the answer memorized, but what this thing really does look like, because they might try to trip you up sometime. Okay? All right, number 4 is just factoring. Shouldn't be a big deal. Kind of was a big deal. I saw lots of pencils hovering over their paper yesterday as they were thinking about what to do. You guys really panic when this first coefficient is not a 1. You really freak out. And I realized that over the last couple years, you've had some teachers that have showed you like some shortcuts and some different methods. They all work. There's nothing wrong with them. Here's the problem with it, though, is you don't remember that method. And therefore, that method is junk. If you don't remember it, it didn't help you. So, guess and check works every time. We've got 2 binomials. In the front, these first 2 terms are created by this term. What times what is 6? 1 and 6 or 2 and 3. Let's just try 2 and 3. It might be wrong. Let's try it. 2x and 3x. What are the factors of 2? 1 and 2. And you know that these 2 last factors, when you FOIL last, create this last term. So it's either 1 and 2 or 2 and 1. Just for kicks, I'm going to try 1 and 2, and I might have to change it. We're just going to guess and check. The outer terms, which in this case are 4x, and the inner terms, which in this case is 3x, are always, always, always combined to get your middle term. That's where that middle term comes from, the outer plus the inner. Can you put 4x and 3x together and get a -1? Yes, if the 4x is a negative, the 3x is positive. If you are not solid on factoring, you need to get solid. It's going to come back and keep biting you in the tail over and over again. Alrighty? Next one. X squared plus 9. Let's factor it. What is that? It is not factorable. And some of you yesterday tried to factor it, and some of you left it blank because you weren't quite sure. Here's why I put this on the review. Let's say x squared plus 9 was a denominator of some crazy thing. And let's say that the question said, where are the vertical asymptotes? Where would they be? It wouldn't have any. If you can't factor it, x can be anything. That means it's continuous. Are there any questions on that? That's why that's on there. Next one, x squared minus 16. That's the difference of 2 perfect squares. That one you can factor into x plus 4 and x minus 4. X cubed plus 27. This one is on there for reasons like number 7, where you have to be able to factor the difference of 2 perfect cubes. I'm going to teach this one more time. Short set of parentheses and a long set of parentheses. The signs spell soap. Same, opposite, a positive. The cube root of the first term goes in the front. The cube root of the last term goes in the back. Square the first guy, stick him in the front. Square the last guy, stick him in the back. First times last goes in the middle. Questions? All right, number 5. Now we jump into the limits. We're approaching 2 from both sides. As you think about the graph of that, whether you know really what it looks like or not, what do you know for sure happens at 2? Yes, there's an asymptote. How do you know it's not a hole? Yeah, we didn't cancel anything out. Or another way is if you plug in a 2, you don't get 0 over 0, so it's not a hole. It's an asymptote. If that is an asymptote, that goes back up to number 2. Is it a one-sided limit or a two-sided limit? 2 sides, because it doesn't say we're coming from the right or the left. It just says 2 in general from both sides. So what's the answer? It does not exist. Number 6. We're approaching 0 from both sides. What happens at 0 on this graph? It's undefined. Does it make a jump, a hole, or an asymptote? An asymptote. What do we do when it's a two-sided limit toward an asymptote? D and E. So there's really no math to do on those guys. You just kind of have to reason your way through it and then write the answer. Yes, ma'am?
So basically when there's not a hole and it's two-sided limit, it's always not exist.
If you're approaching a vertical asymptote, yes, ma'am. Yes, correct. Yes, ma'am.
How did you figure out if there was an asymptote at 0?
Right here, it's on the bottom. X can't be 0. Yep. Anybody else? Okay, number 7. Find the limit as x approaches 1. Is this a one-sided limit or two-sided? Two-sided. It doesn't say from the right or left. It just says as it approaches 1 for this equation right here. Okay, what happens at 1 on this graph? We know it's undefined. How do you know it's a whole? Because you factor in your head. So we factor. It's the difference of two perfect cubes. Same, opposite, a positive. Cube root. Square the first guy, square the last guy, multiply the first and last. So now you can see that you're canceling something out, which tells you it's a whole. So what do I do with that information? How do I find the limit? You can plug in a 1, and it's perfectly legal to do that now because it doesn't make it undefined anymore. So we have 1 plus 1 plus 1 is 3. The next sentence also goes with number 7. It says, identify another function that agrees with f of x, so it agrees with this typed in part, at all but one point. It means this right here. This equation right here by itself, if you type it in your y equals button, looks exactly like this equation right here. The only difference is it agrees everywhere except at one point, at that hole. So your answer is f at x equals whatever you didn't get rid of after you canceled. Because that is a function that agrees at everywhere but one place with the original function. If you type both those in your calculator, it will create a graph right on top of the other one, except for that hole, except for that one point. Also, pay attention. It says create another function. If you just give me this, that is not a function. That's not an equation. That's an expression. Make sure it is an equation. Everybody hear that? Doesn't have to be f of x. You could put g of x. You could put y equals. I would take it. Yes, it has to be this one because it agrees with f of x. It agrees with this one at all but one place. Like if you... Where's my... I don't even have my graphic calculator. Can I borrow somebody's graphic calculator? Do you have one out? I'll borrow Bryce's here. Y equals. If I type in x squared plus x plus 1, thank you, Bryce. And then I type in cube root of x, or x cubed, sorry, minus 1. Whoops. Sorry. Minus 1 divided by. Do you get it now? Do you know what it's saying, Jacob? Just so you guys have seen it, because I did say it out loud. If you graph both of those, there's the first one, and there's the second one. It came in right over the top, so you didn't even notice the difference. It's the exact same equation. It's the exact same function, except right at x equals 1. At x equals 1, there's a little hole, and you can't see it. And I think he'll have it on here. Yeah. See, all of these values agree except for that one place, except for the hole. Everything else agrees. Does that make sense? Thank you, Bryce. Okay. Number 8. Find any x values for which... Wait, what's happening here? There we go. For which this equation is discontinuous. Let's just stop there. What can x not be? 4. So there's part of our answer. At x equals 4, it's discontinuous. So far, we're right. Then it says, are they removable or non-removable? Flip your paper over. We're going to write some stuff down in this little empty space kind of down here on the right. We have f at x equals the absolute value of x minus 4 over x minus 4. When you see an absolute value, and I know that your Algebra 2 teacher probably didn't say this because she didn't need to. You weren't there yet. That absolute value is a fancy way of writing a piecewise function. It's actually 2 equations in 1. Because if I have the absolute value of 5, the answer is 5. If I have the absolute value of negative 5, the answer is still 5. So it's 2 equations in 1. One equation is where you just take the bars off. The other equation is where the inside is the opposite of what it is. So there's 2 different equations going on there. Now what gets produced is a positive number in the end. If I put in a 3 here, 3 minus 4 is a negative answer. So it must be true for all of the x's that are bigger than 4. If I put a 3 in here, 3 minus 4 is negative 1. The opposite of negative 1 is positive 1. So, and 3 is less than 4, so that must work for that equation. So what you have here are two equations with two restrictions. That's a piecewise function. That's what you've just done. So if we think this through, here's your graph. Here's positive 1, here's negative 1. You can either plug in a point and kind of see what happens, or you could do it this way. Divide out x minus 4, divide out x minus 4. What's 1 over 1? 1. Divide out x minus 4, divide out x minus 4. What's negative 1 over 1? So as long as the x is less than 4, if you plug it in, you're going to get negative 1. As long as the x is greater than 4 and you plug in the answer, you're going to get 1. So here's what the graph looks like. We are coming up on 4, and everything's negative 1. Starting at 4, all the answers are 1. That's what that graph looks like. Is that a removable or non-removable discontinuity? Non-removable because it's jump. So non-removable. For those of you that are taking really meticulous notes, you might put whole under removable. Non-removable would be jump or asymptote. Number 9 is also referring to number 8. It says find the limit as x approaches 4 for that function. We've got your graph. We're coming toward 4. What happens? It does not exist. Those are two different values. So we say D and E. Okay, let's take a break. Questions on anything from 1 through 9? Anything I can clarify? Anything I can say again? Anything I can say differently? Yes, ma'am.
Like the thing you just did,
Yes?
when you do equals 1 and equals negative 1, what do you type 1 in?
What?
Hi. Okay, I didn't finish yet. I just bring it to you tomorrow morning.
Yes.
Okay.
No worries, because it's not due tomorrow, right?
No.
Like, I have some time.
Yeah, you have a while.
Yeah, it's fine. Okay, Marina, say that again. I'm sorry.
What did you do, like, in the red?
I canceled. I said x minus 4 divided by x minus 4
Oh, okay.
is 1. Divide and you get a 1. Does that make sense?
Yeah.
Okay. Anybody else? Okay. I'll move on. Number 10. Piecewise function. Find the limit as x approaches 3 from the right. Here's our restrictions. X is less than 3, x is greater than 3. Which one are the numbers on the right? X is greater than 3, the one on the bottom. Okay, I've established which equation I need to use. What do I do with it? Brandon, how do I get to plug in a 3 when that does not say equal to? Right, we're looking for a limit. They're not saying what is the value at 3. They're saying what value are you approaching. So let's put 3 in there. And we have 12 minus 6 divided by 3, which is 2. All right, if we're coming from the left, that's these numbers. Take 3 and plug it in. 3 plus 2 is 5 over 2. Both sides. Why doesn't it exist? Yeah, because we're approaching different values. From the right, we come in at 2. From the left, we're coming in at 2.5. Those are not going to meet up, so it does not exist. 11. For 11, the first thing I see before I even read the question is this guy right here. So I'm thinking maybe I can do something with that, maybe not. This says find the limit. If the limit is approaching 0, then what do I need to remember about this? Right, this is a 1, and Carson's already telling us it's 1/4. Here's what he did in his head, and here's what I used to have to write out that I didn't make you write out. The limit as x approaches 0 for 1/4 times sine x over x. That's asking the same question, right? The rules for limits say you can do 1/4 times the limit as we approach 0 for sine x over x. That's what you've done in your head. That's really what's going on there. And you're going to need to know that in the next couple chapters probably. So make sure you know that's what's happened. So we have 1/4 times, what's this limit? 1. Make sure that you don't say 0. 1/4 times 1 is 1/4. Everybody okay? 12. 12 was tricky for some folks yesterday. The limit is we're approaching -8 from the right. A bunch of you started to like stick in there -7.9999. Why are you making it harder than it is? Like, why can't you just plug in -8? Or can you? If you put in a -8, what's the answer? 0. Is 0 and undefined the same thing? No! There's a big difference in having $0 or having 0 donuts and in having an impossible number of dollars or an impossible number of donuts. So we're approaching 0. That's it. You just plug it in, find your answer. Tomorrow, be careful. Really read the question and really read what they want you to do, and don't make it too hard. Alrighty? Check that out. It's like 5 days in a row. I'm going to take that away from you. 13. It's like every day, I feel like. They give us some givens. They say as we're approaching some sort of arbitrary number, f of x is 5, g of x is -1, and h of x is 2. You're just going to have to apply the rules. And again, this is one of those deals where I didn't make you write out all the steps, but what you're really doing is you're taking 3 times the limit of f of x and the limit of g of x, and you're allowed to do that, rather than putting the functions together. So we have 3 times. That answer was 5. G of x was -1. So you do all that. What do you get? 14. The limit as we approach f of x was, or as we approach a, was 5. And for g of x, it was -1. You multiply those, you get -5. For this one down here, the limit for f of x was 5. You square it and you add 2, you get 27. The cube root of that is 3. For h of x, the limit on that one was 2. Looks like we're supposed to square it, and we're dividing by -1. Questions on the last 4? Alrighty. 14. 14 looks a whole lot like that. You guys did this yesterday, right? Looks a whole lot like the activity we took 2 days in class to do. And most of you, as I walked around, got the first 2 blanks correct, and the third one was tricky. So let's talk about this. The first blank is asking about the limit as we approach -4 from the right. So for f of x, we're approaching -4 from the right, and we're approaching 2. For g of x, from the right, if we're approaching -4, we're approaching 4. Pretty much everybody in here got 6. Now we're approaching it from the left. We approach -4 from the left, and I'm getting close to -2. Approach -4 from the left, and I have a 4 again. The answer is 2. The last one. Some of you got the right answer for the wrong reason, and that concerns me because it's not going to work every time. Here's what I need you to understand. F of x plus g of x. When you add those together, you are creating a third equation that I'm going to call h of x. Bless you. So this is asking, what's the limit as we approach -4 from the right for h of x? It's 6. Let's pretend 6 is up here where my finger is. As we approach, this is h of x. As we approach h of x from the left, we're approaching 2. So the limit as we approach from both sides is what? Doesn't exist because these 2 values are different. Some of you tried to use the 2 graphs to get you there, and you got the right answer on accident. So be really careful, make sure you know why you got doesn't exist. If these 2 values matched, then you'd put that same value in the third box, or third blank, okay? Let's look at the next one. We're approaching 5 from the right for f of x, which is 5. We're approaching 5 from the right for g of x, and it's -2. So we get 3. 5 from the left, still approaching 5. Still approaching -2, and so we still get 3. For this one, the limit from both sides. Don't look at the graphs. Look at your previous two answers. If I come from the right toward 3 and from the left toward 3, the answer is what? 3. Does everybody see the difference in those problems? Yes, ma'am.
So basically, if the previous answers don't match, does not exist, and these things
Correct. Correct. Yes, exactly. Because it's talking about a third equation that we don't have. All right, these guys aren't so bad. You just kind of plug stuff in. The value as we approach 2 for g of x is negative 2. The value as we approach 2 for f of x is 4. So this answer is negative 2/5. We just found this answer to be 4 and that one to be negative 2. So it's negative 5/2. The last one, as we're approaching 2 from the right, for f of x is 4. Square root of 4 is 2. Are there any questions on any of those? Is everybody okay? Okay. 15. Use the intermediate value theorem to show that function takes on a value 12 for an x on that interval. Find the value if it exists. This is in 2 parts. And the reason I wanted to use those words instead of the ones in the textbook is because, number one, I want to make sure you understand it, and number two, you might see that kind of language again, and I want to make sure you know it's asking the same thing your textbook did. It's just worded differently. There's 2 parts to this. The first one lets you use the intermediate value theorem to prove that. Well, there are 2 parts to the intermediate value theorem. What's the first part? Yeah, we need to know if it's continuous. Is this thing continuous all over the place? Yes. So it's definitely continuous on this interval. So your first piece is that you would say f at x is continuous on the interval, or you could say for the x values, negative 3 to 5. If this thing was discontinuous, like let's say it wasn't allowed to be a 5, what would you do? What are you going to do on that test tomorrow if it's discontinuous on the interval? I think what you're going to say is the intermediate value theorem doesn't apply, and you'd skip it and move on to the next one. Does everybody understand? So far we're good though. The second piece for the intermediate value theorem is we have to talk about 12, and we have to see if that y value is between the y values when you plug in these guys. So let's see here. If f at negative 3 equals, let's see, negative 3, plug it in, what do you get? 21. And if f at 5 is, what is it? 5. And 12 is between f at negative 3, sorry, that's a 3, and f at 5. The intermediate value theorem, whoops, I don't know why I did that, applies. Super messy. Okay. Last piece, finding the value if it exists. A value what? Is it asking for an x, a y, a k, a puppy? What's it asking for? Asking for an x because it says that the value is 12 for some x. They want you to find the x. So if our answer was 12 for the equation, let's just solve for x. It is factorable. Whoops, negative 6, my bad, and positive 2, which means x could be 6 or negative 2. Right? Why not? It has to be on the interval. The x's have to be between these two fellas. So not 6, but yes for negative 2. Make sure on your test, if they ask you a question like that, that you double check and make sure everything falls within the interval. Is it possible to have more than one answer down here? Sure. Huh?
You don't was here, but
No, if there's no answer, then you would have found out up here that the intermediate value theorem didn't apply. Good question, though.
it'd have to be just used.
Right. 16. I told you guys to change that to delta x. You can't plug in a delta x because everything becomes undefined. We're hoping that there's just a hole somewhere and that we can cancel some stuff out. So let's distribute so that we have the limit as delta x approaches 0 for, I'm going to multiply 2 times x plus 2 times delta x minus 2x all over delta x. When I do that, 2x minus 2x, those go away. Now what do you want to do? Cancel out your delta x's. What are you left with? So the limit as delta x approaches 0 for 2 is 2. Because 2 is a constant. Last one, 17. You're given a picture. Let's see if you really understand limits. You're approaching this graph, and you're approaching 1 from both sides. So I'm coming in from both sides, and it looks like the graph is approaching 2 different values. So what do you put? We're approaching 3 from both sides. Looks like we're approaching -2. Why didn't I put 1? Right, it's not approaching 1, it's approaching -2. We're approaching 2 from the right. The y value on that one is 0. We're approaching -3 from both sides. It's approaching +3. We're approaching 1 from the left side. So that's -1. 1 from the left side. There we go. -1. And what is the function right at 1? -1. Something you might want to write down here, because it's really easy to get confused. They're giving you the x values, you're giving back the y values. So make sure you know that. All right, do you guys feel a little bit better now that you've seen everything and I've made you listen to every single word I said? Should help. You should be much more prepared for tomorrow, I'm thinking. Replace